Hello everyone. Today we are going to analyze this truss using consistency deformation method. Now we are going to find the degree of static indeterminacy of this truss, that is dSi plus dSe. dSi is the internal degree of static indeterminacy. dSe is the external degree of static indeterminacy. This is the formula for a dSi and this is the formula for a dSe. First, let us find dSi. M is the number of the members. Let us count the members. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So M is 10. J is the number of the joins. 1, 2, 3, 4, 5, 6. J is 6. For dSi, we will get 1. Let us find dSe. R is the total number of reactions we need to find. In the hinged supports, there will be two reactions, vertical and horizontal. So here we need to find two reactions and here two, totally 4. R is 4. Small r is the available equilibrium conditions. There are three equilibrium conditions. Sigma V is equal to 0, sigma h is equal to 0 and sigma m is equal to 0. For DSE also we will get 1. So the degree of static indeterminacy of the truss is 2. Now we have to convert this truss statically determinate. DSI is 1. Internally we have to remove one member. We know that there are 10 members. From these 10 members we have to remove one member. You can see that finding the forces in these two members are very difficult. So out of these two, we can remove any one of them. I am going to remove BE. Then externally, we need to remove one reaction. We know that there are 4 reactions. Out of these 4, we can remove any one. I am going to remove the horizontal reaction from D, that is HD. You can see that I have removed BE and at D I have given a roller support. Previously there was a hinged support and in the roller support there will be only one reaction. Here there is only vertical reaction. Now let us draw the coordinates diagram. In this analysis there are two coordinates. FBE and HD are the two coordinates. Because we have removed both of them, let us keep FBE as the first coordinate and HD as the second coordinate. Let us assume that the force FBE is tensile and let us assume that HD is acting towards the right side. Finally, if we get negative answers, that means our assumption is incorrect. Then we can change the nature of the force and direction. These are the two equations we are going to use to find FBE and HD. Our first coordinate is FBE, so P1 should be FBE, and our second coordinate is HD, so P2 should be HD. The rest of them are deflections. Delta 1L and delta 2L are the deflections in the direction of the coordinates in the released structure. Delta 11, delta 12, delta 21 and delta 22 are the deflections due to the unit force. We will see them very clearly a little later. Delta 1 and delta 2 are the deflections or displacements in the coordinates due to extension or a reduction of the members, or they can be due to temperature changes. In the question, nothing is mentioned about these, so we can assume that there is no temperature change or there is no reduction or extension. In this case, delta 1 and delta 2 will be 0. Then we will get these two equations. We have to make this table. First, we need to find the force P in all of the members. We have to take the released structure and find all the forces. The member B we have released, so there we can't find any force. We can directly write as 0. Let us find the rest of them. Before finding the member forces, we have to find the reactions. At A, we need to find two reactions, and at D, we need to find one reaction. To find VA, I am going to take moment about D. In this case, we have to follow right hand side rule. Clockwise will be positive and anti-clockwise will be negative. VA is acting in the clockwise direction, so it will be positive, and the distance is 5 plus 5 plus 5, so it will be 15. 15 VA. This load is acting in the anti-clockwise direction, so it will be negative and the distance is 10. This load is also acting in the anti-clockwise direction, so it is also negative and the distance is 5. This horizontal load is acting in the clockwise direction, so it will be positive and the distance is 4. For VA, we will get 12 kilonewton. Let us apply this rule and find VD. VA and VD are acting upwards, so both of them are positive. These two loads are acting downwards, so both of them are negative. For VD, we will get 16 kilonewton. Using this rule, we can find HA. HA is acting towards the left side, so it will be negative. This load is acting towards the right side, so it will be positive. For HA, we will get 10 kilonewton. Now we need to find the member forces. Before that, we need to find the angles. Let us take this triangle. In this triangle, let us find the angle theta. Tan theta is opposite side by adjacent side. The opposite side is 4 meter and the adjacent side is 5 meter. So it will be 4 upon 5. So theta will be 38.66. If this angle is 38.66, this angle and this angle also should be 38.66. First, I am going to take joint D and to find the member forces. I am going to use method of joints to find the member forces. Similar kind of statically determinate structure I have already analyzed. This is in the description. You can see that for getting more idea in method of joints. Also, I am going to use only cos theta. If you wanted to use sin theta as well, you can do that. 90 minus 38.66, we will get this angle 51.34. In the joint D, first we have to use this rule because there will be only one unknown. This is acting upwards, so it will be positive. FDE is inclined. We have to resolve it in the vertical direction. To make it vertical, we need 51.34 degree. So with FDE, we have to multiply cos 51.34. It is acting upwards, so it will be positive. For FDE, we will get minus 25.61. Let us apply this rule and find FCD. FCD is acting towards the left side, so it will be negative. FDE is inclined. We have to resolve that in the horizontal direction. To make it horizontal, we need 38.66 degree. So with the FDE, we have to multiply cos 38.66. It will be acting towards the left side, so it will be negative. Just before we have found FDE, we can apply that. Negative into negative, it will become positive. For FCD, we will get 20 kilonewton. Now we are going to take the joint E and to find the member forces. If this angle is 38.66, this angle also should be 38.66, and this angle will be 90 minus 38.66. It will be 51.34. First, we have to use this rule because there will be only one unknown. This is acting downwards, so it will be negative. FDE is inclined, we have to make it vertical. To make it vertical, we need this angle. So with FDE, we have to multiply cos 51.34. Since it is acting downwards, it will be negative. We can apply the value of FDE. Already here there is negative and this is also negative. So negative into negative, it will become positive. FCE is acting downwards, so it will be negative. For FCE, we will get a 4. Then we have to apply the rule sigma h is equal to 0. This is acting towards the left side, so it will be negative. We have to make FDE horizontal. To keep it horizontal, we need this angle. So we have to multiply cos 38.66 with the FDE. it will be acting towards the right side, so it will be positive. FDE is a negative 25.61. We can apply that. For FEF, we will get minus 20. Now let us take the joint C. If this angle is 38.66, this angle will be 90 minus 38.66. It will be 51.34. First, we have to apply the rule sigma V is equal to 0. FCF is inclined. We have to resolve it in the vertical direction. To keep it vertical, we need this angle. So with the FCF, we have to multiply cos 51.34. Since it is acting upwards, so it will be positive. FCE is acting upwards, so it will be positive. Just before we have calculated FCE, we can apply that. For FCF, we will get this. Now let us apply this rule. FCD is acting towards the right side, so it will be positive. FBC is acting towards the left side, so it will be negative. FCF is inclined. We have to resolve that in the horizontal direction. To keep it horizontal, we need this angle. So with the FCF, we have to multiply cos 38.66. Since it is acting towards the left side, it will be negative. We can apply the value of FCF. Here already there is negative. So negative into negative, it will become positive. And let us apply the value of FCD. For FBC, we will get 25 kilonewton. Now let us take the joint B. In the vertical direction, we have only one member FBF, so that will be 0. Let us apply this rule. This is acting towards the left side, so it will be negative, and this is acting towards the right side, so it will be positive. For FAB, we will get 25. Now we are going to take the joint A. FAB we have already found. We have to only find FAF. Using this rule, we can find that this is acting upwards, so it will be positive. FAF is inclined. We have to resolve that in the vertical direction. To keep it vertical, we need 51.34 degree. So we have to multiply FAF with the cos 51.34. Since it is acting upwards, it will be positive. For FAF, we will get minus 19.21. Let us enter the values of P. Now we are going to find the values of K1. Let us see how to find. We have to remove all of the loads from the truss, and then we have to apply unit force in the direction of the first coordinate. Our first coordinate is FBE. So in the direction of FBE, we have to apply unit force. As I said earlier, we have to remove all of the loads. Also, we should not consider HD. You can see that I have removed all of the loads and I have applied unit force in the direction of FBE. We need to find these three reactions. You can see that in this truss there is only internal force. There is no external load. If there is no load, these three reactions will be 0. VA, HA and VD will be 0. We can remove the reactions. Here I have removed. Now we are going to find the member forces. AF, AB, ED and DC are the zero member forces. If you do not know how to find the zero force members, I have made a video regarding that. Video link is in the description. You can click the link and watch the video. It will be very helpful for you to find the zero force members and how to find the member forces with the shortcuts. If you cannot find the zero force members using the shortcuts, let us take the joint D and see how the member forces will become 0. When we use this rule, FDE will be 0, and when we use this rule, FCD will be 0. But if you know the shortcuts, no need to do these. Directly we can apply 0. Now let us take the joint E and find the member forces. ED is the zero force member, so no need to take that. First we have to apply this rule. The unit force is inclined. We have to resolve it in the vertical direction. To keep it vertical, we need this angle. So with the unit force, we have to multiply cos 51.34. It will be acting downwards, so it will be negative. FCE is acting downwards, so it is also negative. For FCE, we will get minus 0.625. Let us apply this rule. Unit force is inclined. We have to resolve it in the horizontal direction. To keep it horizontal, we need this angle. So with the unit force, we have to multiply cos 38.66. Since it is acting towards the left side, it will be negative. FEF is also acting towards the left side, so it is also negative. For FEF, we will get this. We have found the member forces in CE and FE. To find the other member forces, we can apply shortcut. You can see that it is symmetrical. So the force in BE will be equal to the force in FC. So it should be 1. The force in FE will be equal to the force in BC. And the force in EC should be equal to the force in FB. Even though there is a shortcut, still I am going to find the member forces using the method of joints. Let us take the joint C and find the member forces. Let us apply this rule. FCF is inclined. We need to make it vertical. To keep it vertical, we need 51.34 degree. So with the FCF, we have to multiply cos 51.34. Since it is acting upwards, it will be positive. FCE is acting upwards, so it is also positive. In the previous step, we have calculated FCE. We can apply that. For FCF, we will get 1. Now let us apply this rule. We have to resolve FCF in the horizontal direction. To keep it horizontal, we need this angle. So with the FCF, we have to multiply cos 38.66. Since it is acting towards the left side, it will be negative. FBC is acting towards the left side, so it is also negative. Just before we have found FCF 1, we can apply that. For FBC, we will get minus 0.781. Now let us take the joint B. In the previous step, we have calculated FBC. We have to only find FBF. For that, we need to apply this rule. We have to resolve the unit force in the vertical direction. To keep it vertical, we need this angle. So we have to multiply the unit force with the cos 51.34. Since it is acting upwards, it will be positive. FBF is acting upwards, so it is also positive. For FBF, we will get minus 0.625. Now let us enter the values of K1. For BE, we have applied unit force. Let us enter other values which we calculated. I have already told that the member forces in BC and EF will be same. The member forces in CE and BF will be same. And the member forces in CF and BE will be same. Now we are going to find the values of K2. To find the values of K2 in the direction of HD, we have to apply unit load. When we do this, we should not consider any loads. Also, we should not consider BE. I have applied unit load in the direction of HD. We need to find these three reactions. By applying this rule, for HA, we will get 1. To find VA, we can take a moment about D. VA is acting in the clockwise direction, so it will be positive, and the distance is 15, so 15 VA. For this horizontal reaction, there is no perpendicular distance about D, so we should not consider that. In this case, there is nothing, so VA will be 0. Using this rule, we can find VD. Otherwise, we can take directly VD as 0. Because there is no vertical load or vertical reaction, in this case VD will become 0. Let us take the joint D and find the member forces. Let us use this rule. We will come to know that FDE will be 0. Otherwise, you can apply shortcut. These shortcuts, as I told you already, I have made a separate video. You can click the link and watch that video. Let us apply this rule. This force is acting towards the right side, so it will be positive. FCD is acting towards the left side, it should be negative. For FCD, we will get 1. If FCD is 1, FAB also should be 1. If this is 0, this also will be 0. We can take the joint B and apply the rule sigma V is equal to 0. There is only one vertical member, that is FBE, so that will be 0. Then we can take the joint E. We can apply the rule sigma H is equal to 0. This is already 0, so FFE will be 0. And when we apply the rule sigma V is equal to 0, FCE is also 0. Then we can take the joint C. We can apply the rule sigma V is equal to 0. This is 0. So this also should be 0 because there is no other vertical force. Now let us take the joint C and to find the member force FCB. We can apply this rule. FCD is acting towards the right side, so it will be positive. FBC is acting towards the left side, so it will be negative. We already know FCD 1, we can apply that. In this way, for FBC, we will get 1. Let us enter all of the values of K2. We did not consider BE, so for BE, we have to apply 0. The rest of the values we have found, we can apply. Now we are going to find the length of the members. Most of the length of the members are given. Length of AB is 5, length of BC is 5, CD is 5, and FE is 5. Length of BF and the length of CE is 4. We can find the lengths of AF, BE, FC, and ED using the Pythagoras theorem. That is root of 5 square plus 4 square. We will get 6.403 meter. Let us enter all of the lengths. Then we can find pk1l, pk2l, k1 square l, k1 k2l, and k2 square l. Then we need to find the summation of these 5. When we add these, we will get this. When we add these, we will get this. When we add these, we will get this. And when we add these, we will get this. And finally, when we add these, we will get this. This is the formula to find delta 1L. This is the formula to find delta 2L. This is the formula to find delta 11. This is the formula to find delta 12 and delta 21. And finally, this is the formula to find delta 22. In the question, nothing is mentioned about the area or Young's modulus of the members. In this case, we can assume that area and Young's modulus for all of the members is constant. In these two equations, we can apply all of them. We have found everything. No need to take AE because it will be eliminated. Using a calculator, we can solve these two equations. Then we will get P1 and P2. We know that P1 is FBE. For that, we have got a negative value. That means the assumption is incorrect. We assumed that P1 is a tensile, but actually it is compressive. For P2 also, we have got a negative value. We have assumed HD to be acting towards the right side, but actually it is acting towards the left side. Using this formula, we can find the member forces in all of the members. If you got positive values, that means the nature of the members is tension. And if you got a negative value, the nature of the members is compressive. No need to find the vertical reactions. It is same as the vertical reactions which we have calculated in the released structure. By applying this rule, we can find HA. But for HA, we will get a negative value. That means the assumed direction is incorrect. We have to change the direction. Here you can see that I have changed the direction. Inside the truss, I have entered all of the member forces. Now we are going to end this session. Thank you for watching this video.